Hi, Andrew here, and today,
I'm free.
to bring you the time that a thoroughly confused Flatzoid debunked the ideal gas law.
Hi, today I thought I'd do something a bit different.
Yes, it's not every day that a spray painter overturns a scientific law that has stood for 2 centuries, but let's see how he goes.
I've been listening back a few times now actually that FED debate with Brian and the changing of density of the gas if at a temperature. So why don't we test it out? So I thought, okay, let's do a practical demonstration, because if it is what Nathan's saying, it's because it's increasing the expansion is just increasing the volume of the container due to the gas is just moving faster, which is true.
Well, yes, the density will decrease if the container expands, but as we will see, the container didn't expand. And the ideal gas law says that if the temperature of the gas increases, the pressure will also increase by the same proportion, and the density will remain the same. More importantly, none of this will change the mass of the bottle or the mass of the air it contains, so the weight of the object will not change.
So here was the demonstration. I have an ordinary heat gun that I just used to heat up the ordinary water bottle that's on the scale, so we can deduce for ourselves what's really going on. Okay, so here's the first demonstration. I'm just trying to heat the bottle up. Ignore the scale as it's showing it going down in the weight at the moment, because it's actually just the hot air from the breeze that's pushing on the scale that's coming out of the heat gun. So it doesn't really matter what it's showing out of. The key factor is, in the beginning it showed 0 because I set it to 0, I teared it out, and then what I want to see is when I put the heat gun off, what is going to happen if the heat has actually made it less dense, and thus it will weigh less, and then if it cools down, then it will become heavier. So we're actually looking for a minus if I put the heat gun down. So let's just watch and see what happens. Okay, and here I decided to put the heat gun off. Yeah, we can see, okay, it's sitting -1, so that's already showing it's less denser than what it was before it was heated up. Oh, there we go. And now it's back to what it was originally before it was heated.
So it took 90 seconds to heat it up and lose zero point 0.1 grams, but only 10 seconds for it to cool down and regain that zero point 0.1 grams. That seems legit. Now, we all know that flat earth scientists are adamant that an experiment must only ever have one independent variable. So Flatzoid dutifully conducted a second run of his experiment where he varied two things: the volume of the air in the bottle and the amount of heat applied to it.
I tried to do it again the second time. Yeah, you see I actually took some air out and paired it, and then I decided to use even more heat this time just to see if it will give the same effect. Well, as you can see, I'm adding more heat, and you're going to hear the bottle expanding. You're going to hear it crumping up and expanding as it's going along. Okay, so yeah, I've put it off, and you can see it's on -2 where the previous it showed -1.
And he found out that two things changed: the size of the bottle and the amount of weight the bottle seemed to lose. Good luck working out how to correlate changes in two independent variables with the changes in two dependent variables. And it's going to be particularly difficult since the only thing he quantified was the weight the bottle seemed to lose. Nevertheless, he has a hypothesis, or two.
Option 1, it could just be the pressure hitting the whole bottle against the scale with more force and thus giving it less weight.
So if it's pressing on the scale with more force, it's because the object is lighter? That seems legit.
or it could just be that it was just the density changed, like Brian said.
So scales measure density? That seems legit. Whatever his misunderstandings, he is convinced that heating a bottle of air makes it lighter. Now, I won't mention that the first test only barely changed the measured weight by one division of the scales, nor will I mention that in the second test he blasted a lot of hot air on the pan of the scales, potentially heating up the electronics. Of course, there's absolutely no way that could affect the result, because the user manual for the Mettler Toledo BBA 242 series of paint scales certainly doesn't say, on page 9, to avoid excessive fluctuating temperatures, nor does it say on page 24 that the correct operating environment of the scales is 10 to 30 degrees Celsius. So, after his successful falsification of the ideal gas law in March 2021, we can all trust that Flatzoid will have never relied on the ideal gas law for any of his arguments since.
Gay-Lussac's law, Avogadro's law, Dalton's law, and ideal gas law. The ideal gas law is actually just like Gay-Lussac's law. They actually work hand in hand together.